Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the basics of chemical bonding. Initially, let us consider two atoms A and B. So, initially, the atoms A and B possess high energy. So, during the formation of the molecule, the energy will be lost. So, molecule will possess low energy, whereas atoms possess high energy. So with the result, molecule is more stable than the corresponding atoms. So in order to attain stability, atoms combine to form the molecule. So here, coming to the chemical bonding, it can be defined as the force of attraction between the two atoms or group of atoms. So let us consider few examples. For example, if we consider NaCl or methane, or if we consider ammonium chloride, even benzene, here all these molecules are stable since there exists an attractive force which holds all the atoms together in the molecule. So the force of attraction between any two atoms or group of atoms that results in the formation of a stable molecule is called chemical bonding. And especially this chemical bond can be expressed in terms of ionic bond or covalent bond. That means a chemical bond formed by the transfer of electrons is called ionic bond. At the same time, a chemical bond formed by the sharing of electrons is called covalent bond. So, before discussing about ionic bond and chemical bond, one should know what is meant by valency. In general, the combining capacity of an atom is expressed in terms of valency. So, the combining capacity of sodium or chloride, carbon or hydrogen. So, any atom can be expressed in terms of valency. So, valency means the number of hydrogen atoms or the number of chlorine atoms or double the number of oxygen atoms with which an atom of the element combines is called valency. So let us consider few examples. For example, if we consider NaCl, so the valency of sodium can be calculated by knowing how many number of chlorine atoms are required. So here the sodium reacts with only one chlorine atom and hence the valency of sodium is 1. So valency means the number of hydrogen atoms or the number of chlorine atoms or the double the number of oxygen atoms with which an atom of the element combines is called valency. So here sodium combines with one chlorine atom. That's why the valency of sodium is 1. So if we consider aluminium chloride, here aluminium combines with 3 chlorine atoms, and hence the valency of aluminium is 3. And if we consider carbon dioxide, here the carbon combines with 2 oxygen atoms. Here we have to double the number of oxygen atoms. So the valency of carbon can be obtained by doubling the number of oxygen atoms. Here carbon combines with 2 oxygen atoms. So 2 into 2, that is 4. So the valency of carbon is 4. At the same time, if we consider water, here the valency of oxygen is, here oxygen combines with 2 hydrogen atoms, and hence its valency is 2. Similarly, if we consider ammonia, here the nitrogen combines with 3 hydrogen atoms, and hence its valency is 3. So in that way, it is possible to calculate the valency of an atom. And always the nature of chemical bond is explained by electronic theory of valency. So what type of chemical bond is present in the given molecules can be explained by the electronic theory of valency. It is also called as chemical bond theory or modern theory of valency. So coming to the electronic theory of valency, it is proposed by Covalent and Lewis. They proposed electronic theory of valency in order to explain the nature of chemical bonding. That means what type of chemical bond is present between the atoms in the given molecule. So nature of the chemical bonding is beautifully explained by Covalent and Lewis. So coming to the important points of electronic theory of valency, always the electrons present in the outermost orbit are called as valency shell electrons, and they are involved in the chemical bonding. So the electrons present in the valency shell, that is outermost orbit, are involved in chemical bonding. So only the electrons which are present in the valency shell, that is outermost shell, participates in chemical bonding, and the electrons which are present in the inner cells are called as core electrons. So when we consider fluorine, its atomic number is 9 and configuration is 1s2, 2s2, 2p5. So the outermost orbit, the electrons present in the outermost orbit participate in chemical bonding. So these electrons are called as valency electrons, whereas 1s2 electron, they are present in the inner shells, and hence they are called as core electrons. And coming to the second point, except inert gases. So once again, if you consider the atoms present in the periodic table. So let us have a rough draft about the periodic table. So these are called as S block elements. So the atoms which are present on the right side of the periodic table are called as S block elements. On the right side are called as P block elements. Especially here the last group elements are called as inert gases. So the atoms which are present in between S and P block elements are called as D block elements, and F block elements are placed below the long form of the periodic table. So here, except the inert gases, all the atoms will participate in chemical bonding. So why inert gases are not participating in chemical bonding? So let us know which atoms are called as inert gases. Especially the inert gases include helium, neon, argon, krypton, xenon and radon. So these elements are called as inert gases. They do not participate in chemical bonding. So why they do not participate in chemical bonding? So these inert gas elements are also called as zero group elements. So because of the stable configuration. So what is the stable configuration? That is NS2 and NP6. So these zero group elements consist of stable configuration, that is NS2 and NP6. With the result, they do not participate in chemical bonding. So other than noble gases, if we consider any atom, these atoms attain stability by acquiring nearest noble gas configuration. So except noble gases, all the atoms will try to attain stability by acquiring nearest noble gas configuration. For example, if we consider hydrogen, it consists of only one electron, but due to the formation of chemical bonding, that means if we consider hydrogen molecule, so here a chemical bond is formed between the two hydrogen atoms. With the result, each hydrogen atom will get the helium configuration and attains the stability. So in that way, each and every atom will attain stability by acquiring nearest noble gas configuration. So why these inert gases are stable? So because of the octet configuration. So whenever if we consider inert gas elements, so they contain octet configuration. What is meant by octet rule? An atom must possess 8 electrons in its valency shell, that is outermost orbit, for stability. So what is octet rule? An atom is supposed to contain 8 electrons in the outermost shell to attain stability. So for that stability, all the atoms except noble gases will attain stability by acquiring nearest noble gas configuration. Especially these 8 electrons are attained by any atom either through transfer of electrons or by sharing of electrons. So, except noble gases, all the atoms acquire 8 electrons in their outermost orbit either by the transfer of electrons or by the sharing of electrons. So, when we consider transfer of electrons, it results in the formation of ionic bond, and always by the sharing of electrons a covalent bond is formed. So, when we consider sodium chloride, here a chemical bond is formed by the transfer of electrons from the sodium to the chloride. So always this sodium having one extra electron, that sodium will lose that electron and results in the formation of Na+, whereas the chloride is having one electron deficiency and hence it gains the electron lost by the sodium and results in the formation of Cl-. So whenever Na+ combines with Cl-, it results in the formation of ionic bond between sodium and chloride. So here what happened? Transfer of electrons takes place between the sodium and chloride, and hence it is good example for ionic bond. And whenever if we move to HCl, here hydrogen consists of only one electron in the outermost orbit. Coming to the chlorine, it consists of 7 electrons in the outermost orbit. So to attain stability, hydrogen will contribute 1 electron, whereas the chlorine atom will contribute 1 electron. And with the result, always a covalent bond is formed between the hydrogen and the chlorine atom, and always that results in the formation of the covalent bond. Here the electrons are shared between hydrogen and chlorine atom, so it results in the formation of a covalent bond. That's why by the transfer of electrons always it results in the formation of ionic bond, whereas by the sharing of electrons always it results in the formation of a covalent bond. Let me discuss about few multiple choice questions based upon the electrochemical theory of valency. So, valency of an atom or an element indicates, it always indicates the combining power with hydrogen atoms or chlorine atoms or with the oxygen atom. So, option A is the right answer. Most energetic species among the following is. So just now we discussed, so always atoms combine to form the molecules. So the molecules are more stable. So the most energetic species will be atom. And here the neon is the stable atom because it is the inert gas. So it will not participate in chemical bonding. So the most energetic species is fluorine atom. So option C is the right answer. When two atoms of chlorine combine to form a molecule, that is chlorine gas, the energy of the molecule is, always remember the energy of the molecule is lower than that of its corresponding atoms, and hence option C is the right answer. The electronic theory of valency was proposed by, it was proposed by Cosell and Lewis. Especially Cosell explains the formation of ionic bond, whereas Lewis explains the formation of covalent bond. The number of valency electrons in the carbon atom is, so atomic number of carbon is 6 and its configuration is 1s2, 2s2, 2p2. So here the valence electrons present in the carbon are 4. So option C is the right answer. The electronic configuration of an atom is 1s2, 2s2, 2p6. It can form. So the outermost configuration is 2s2, 2p6. That means it contains 8 electrons. And hence it will not form any compound. So option D is the right answer. No compounds will be formed by an atom with the configuration 1s2, 2s2, 2p6 since it already acquired octet configuration. Octet rule is not valid for which molecule? So when we consider the structure of these molecules, that means coming to the carbon dioxide, here each and every atom contains 8 electrons. Coming to the water, here also oxygen atom contains 8 electrons, whereas hydrogen atoms contains 2 electrons. So octet rule is valid for water also. Coming to the oxygen atom, a double bond is present between the two oxygen atoms. Each oxygen atom contains 8 electrons. Here also octet rule is valid. Coming to the carbon monoxide, always remember that 6 electrons are present on the carbon atom, whereas 8 electrons are present on the oxygen atom. So octet rule is not valid for carbon monoxide. So option D is the right answer. The representation of valence electrons in the form of dots is called. So for the first time, Lewis introduced dot model for the representation of valency electrons. So option D is the right answer. That is Lewis structure. Which of the following atom do not form chemical bonds? Especially noble gases will not form chemical bonds. So coming to the options, here option C, helium is the noble gas and hence it do not form chemical bonds. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.